One of the key aspects in artificial intelligence, machine learning, in the last few years has been around productionizing and scaling the use of these services. And for that, at Data Futurology, we've created an event which we've run a couple years now. We call it Advancing AI. So we want to be advancing the deployment of these systems in production at scale. We also want to advance the use of these capabilities throughout the organizations. And we always cover the most relevant and best topics that we can find. And we're definitely keen to see you there in the next one. This year's 2022's Advancing AI is going to be in person in Melbourne, April 6th and 7th at Crown Promenade. I hope to see you there. The lineup is looking fantastic. Please check it out on datafuturology.com. It's all going to be geared around productionizing these systems, scaling them, and increasing the adoption of AI within our organizations and outside. April 6th and 7th, Melbourne, Crown Promenade, Advancing AI with Data Futurology. Thank you so much. See you there. I'd like to say a big thank you to our sponsors, Talent Insights. Talent Insights are Australia's leading specialist data recruitment business. With offices in Sydney, Melbourne, and Brisbane, they're experts at providing recruitment strategy and building data teams for clients across industries Australia-wide. They provide recruitment solutions for all roles across the data lifecycle, including data engineering, data science, advanced analytics, customer and marketing insights, business intelligence, data product managers, and data governance. They're skilled at finding the best permanent and contract hires for your business needs, as well as statement of work, project-focused data resources. At Talent Insights, relationships matter most. I can say from first-hand experience, Talent Insights are fantastic to work with. Whether you're a business leader within an HR network or a specialist data candidate, Talent Insights should be the first company you turn to for all your data recruitment needs. Find them at talentinsights.com.au. Welcome to another episode of Data Futurology. At the moment, we are doing our Advancing AI series. And in this series, we are covering the challenges and topics that are in leaders' minds when adopting AI into the organization and scaling up the use of AI within the organization. So we are towards the end of the series. This is episode 12. We got one more, which is next week back at the regular time. So 8:30 a.m. for Eastern Standard Time. So definitely come back for that one. Today, we're going to be talking about the use of AI in the energy sector. Super exciting topic. I know that a lot of people have been asking us to cover this area. And we're going to tell you, no one better than Lauchlan Wallace. So he's the Chief Data Officer from Woodside. Lauchlan, a pleasure to have you on the show. How are you doing today?
I'm very well today. Thank you very much for having me. I really appreciate it. Just a quick apology. I'm now at home because we're just coming out of lockdown, so there might be a couple of home noises in the background. Apologise for those in advance.
No, do not worry at all. Completely understandable. And it was quick acting there for the snap lockdown, but no problems at all with the background noise. So before we kick off, I need to say thank you to our sponsors who are here on my right. So Yellowfin, Databricks, Ambiata, and Talent Insights. They help us and support us in bringing this content to the community for free. Please show them some love wherever you can. They've been helping us and supporting us for a long time. So it's great that we get to do this for you guys. And one of the other things to say is very keen to see a conversation happening on the chat. So as while we go through the discussion, if you hear anything that you really enjoy, any aha moments, any further thoughts, pop them in the chat, and we'll get some comments going there. We'll also use the Q&A section for any questions that you have during the session for the guest. Pop them in the Q&A section. For the questions that go in, other people can upvote them. So if you do like a question that's there, give it a thumbs up. And finally, we have a poll for today, which is a quick 4-question poll. I might kick it off now. So you'll see a pop-up
come up for you to allow you to answer the poll, and I'll leave it open for about 15 minutes, and then we can go through the answers. So thanks for that. And then Lauchlan, I was wondering if you could kick us off by telling us a little bit about your role and your remit, what the responsibilities are, and then we can take it from there.
Certainly. So my current role is the Chief Data Officer at Woodside. I guess it's best described as a role that has two key functions to it. And I'm going to steal some language that I saw in one of your previous podcasts, which was defensive and offensive role of the Chief Data Officer. The first one is the defensive side, which is about getting your data correct, getting it usable, getting it governed well, making sure that it's secure and that type of stuff, fairly typical sort of governance role. And the other one is once you've got your data into a state which is suitable for the business, it's been governed well, it's been managed well, it's been treated as an asset, it's to realise the value of that asset. So that is the offensive side. So how do you go about getting value from data and infrastructure that you've invested in? And that's where the AI, the machine learning comes into it, so that you can go from an organisation that has data to an organisation that is using data very well.
That is great, man. That's really good, and I like that approach of the offensive versus the defensive. That's really. I
have borrowed shamelessly from your previous podcasts.
No, that's great. I am very, very happy to hear. That's exactly what we want to do. And then tell me, how do you look at the work, or splitting up the work in an overarching way? It can be either in the offensive or defensive bucket. But can you give us some areas that you've tackled during your time there at Woodside?
I think the best way to describe what we do is we assign roles and responsibilities throughout the business. The amount of data that we collect and the breadth of the data that we collect is significantly large and probably beyond the capability of a centralised organisation. So we hold the business to account for the data that they create. They're there to create it in a suitable manner to suitable quality for the business case that they are using it for. So that the governance is distributed to the business, and we provide a later oversight to that. Then what we do is we have an infrastructure that allows the business to consume that data independent of the data creation application. And that allows us to service the business requirements within a certain part of the business and in other parts of the business to answer business-related questions. So we're trying to create layers of separation between creation and consumption for our data ecosystem. And what that does is allow us to use data in multiple formats, in multiple applications, and for multiple use cases without too much disruption to the creator and the source system.
That's excellent. That's really good. So I definitely want. I got a couple of follow-up questions from there. I might first ask you about how you interact with the business to get them to make them own the data quality that they're providing. How does that relationship or those communications look like? What's the structure? Obviously, as much as you can share.
I think I'm lucky in the fact that our organisation is very data literate. It's an engineering organisation, and it's full of people who have a sort of very significant STEM background. So a lot of maths knowledge, a lot of numeracy. So the understanding of the value of data hasn't been a huge hurdle for myself. Mm-hmm. I think with the amount of energy that is globally around the sort of data story and the value of data, coming in has been a lot of a significantly easy exercise. It's been an open door, really, to have the conversation about we need to understand our data. We need to be able to present it to the business in a consistent manner so that you know how and when to go and find the information that you're looking for. You know you know whether a piece of information you are looking at is the source of truth, and how and when you should use it. So creating those frameworks and having those conversations within the business on a one-to-one or one-to-many basis has actually been quite easy because of the qualifications of the individuals I'm talking to, and the expectation that this is the world that we're heading into in sort of the new age of digital and data science.
Mm-hmm. Yeah, that's great. Definitely an important and valuable leg up right there. And tell me your views on the ecosystems. So you mentioned briefly there a separation of areas. What does that look like for your, and how have you guys designed and built the ecosystems internally?
I think possibly the best the way to illustrate this point is I might talk about an AI application that was built within Woodside and how we created it, and then how we have deployed some of that information, and then how we've grown on top of that. And it's a very simple application. So, and as I walk through the story, we'll be able to pick out some of those bits that I think you're referring to.
Great.
So let me start with what it is we created. When you go through an industrial plant, similar to the one we run, you'll find lots of pumps and machines that use oil as a lubricant. Now, typically on the side of the machine, you'll see a sight glass, which tells you how much oil is left in that machine. Because it's a sight glass, it takes someone to walk around and have a look at it, make an assessment, write it down, and then assess whether the machine needs new oil or not. So a simple machine, our AI application was to put a camera looking at that sight glass and take a photo and get a machine learning algorithm or an AI algorithm to interpret what the level was. So step one, we got an AI to read the sight glass. It's very simple. It's almost like a fuel gauge in your car. Now that we've got a machine to read it, we can increase the frequency of which it's being read and create a time series result from the result that the AI is creating. So instead of doing it once a week or whatever the cadence was for the human, we can now do it once every 3 hours or something. And from there, we can create a time series. Now, if we publish that piece of information, we've created a piece of information that other people can use to interpret things about the behavior of that piece of equipment. So how do we do that? So first of all, what we've done is we've created a separation between data and application. Now, data science and machine learning, in my view, is an application. It is a set of tools that people are using to perform a workflow or an activity. What they're using is the data. So we create a separation between the image being stored so that many people can use it and the application that the data scientists are using to interpret that image. They then publish the result of that back as a new data source into the same data ecosystem. So they become a source of information, not just a consumer, but a source of information. So now we have another data set being recorded that's available for other people. So there's a distinct layer or separation of activities between the data ecosystem and the application or workflow ecosystem and the people interpreting that data. So then what is now available is you've now got a data set of time and value for that sight class in this case. Now that can be consumed by an engineer or can be consumed by someone who's maintaining that piece of equipment. And it can then be used for further machine learning, looking at predicting how that piece of equipment is performing based on a piece of information that we didn't have digitally recorded previously. So it can then service multiple use cases. One of the things that we found around adoption, which I think is a very good point, is having a lot of numerically savvy individuals within the organisation meant that they were using numerically literate tools already. And pushing new applications onto them was probably an adoption problem that we didn't need to tackle. So under this ecosystem and how we're constructing our data versus application ecosystem, we were able to create data science models, bring them back into the data ecosystem, and then publish them into applications that the engineers in this case or other users within Woodside were already familiar with and using. So we didn't have an adoption around applications, and it meant that all we needed them to look at was a new data stream within an existing ecosystem that they were familiar with, and it became a very powerful adoption tool.
That's really interesting. Really good to have the
a bit long-winded answer for you for the
no,
question.
you're kidding me? It's great. It really highlights the power of the separation between the data and the applications, and having the applications right back to the data, and then for that data to be able to be reused and for it to be integrated wherever people are, like whatever their current workflow is.
I think the nirvana for data is to have it consumed as many times as you can. So if I can present that little piece of information from a sight glass into a maintenance dashboard, so they're visualizing some information, but also into an engineering algorithm who's diagnosing issues that may or may not be present in that piece of equipment, then I have doubled the value of the asset that I've created. And as I said, we're trying to treat data as an asset that is valuable to the business and that people can leverage value from.
That's fantastic. That is really great. And where did the design for the ecosystem come from, or when did it first come into fruition within the organization?
So you might need to walk back a bit through my history in as an engineer initially, but I guess in 2014 we started data science within Woodside, and that was quite an adventure, which I really enjoyed. I really, being a data nerd myself and being one of these people in the organisation who are numerically savvy, I really enjoyed solving problems using data. What became apparent was a couple of things we did, which I thought was very powerful, was when we went into a source system, we went and got all of that information. So if we were going to do a project on a certain system, we'd make sure that we went into that system and didn't just get the data that we need, but all the other surrounding data, so that when we came back to the next problem, it became a lot easier. And that we didn't have another ingestion problem. We certainly had a feeling that a large part of any data project was actually, or data science project was actually getting the data available. So we sort of tackled that issue. In doing that, other parts of the business started to come and talk to us and say, look, we know you have the data, can you make it available to us? And this is because the business was, as I have repeatedly said, quite numerically literate and was very, very data driven. We started to see that data science weren't the only consumers of this information. And the final one was around the piece around adoption that I said. We wanted to push this data into as many places as we possibly could. So how do we service a ecosystem that was able to consume data in multiple formats and multiple applications? And I said that was a final point, but I've just remembered a really critical third one. We wanted to, and the final thing which really pushed us into this ecosystem was the deployment of data science models. Now, I've briefly touched on the AI model. Now, where we wanted to get to was having our data scientists and anyone else using data investing their time in the creation of the valuable product, the algorithm, and not in chasing the data. So you go back to my first point where I was saying we went into a system and got all of the data. Well, the next bit was when we had the data, we had to make sure it was suitable for deployment, because another observation we sort of had in our early years was we'd build an algorithm, but in doing so, we did a lot of cleansing and cleaning and manipulating of the data asset to suit the algorithm that we were building. And then when we came to deploy it, we had the source system had data treatment, and we had a deployment issue. So the final thing we did was we wanted our data scientists to build their algorithms on the same data feed, not just the same data set, but the same data feed that they were going to deploy their algorithms on. So we had this, we separated data science and data and said, okay, data have their own dev, test, prod environments, which is independent of data science, who also have their dev, test, prod environment. And the data science test environment will be feeding off the data prod environment so that when they come to deploy their ecosystem, or their algorithm, sorry, it's on the same data feed. What we didn't realize at the time, but the power of that model and the acceleration in time to value was incredible, to the point now where we've done a few more bits and pieces in the ecosystem. But once the data scientist has got to the point where they've finalized their model and they're ready to deploy, deployment is measured in minutes, not hours or days. We can have that system ready and just deploy it. I think the quickest we've had it is under 5 minutes, but generally a little bit of sort of curation and sort of governance, and we're certainly within an hour we can have that algorithm deployed and then being consumed within the business. So there's a number of layers there, there's a number of reasons for it, but it was a bit of a journey. But now we've got an ecosystem where these separation duties has proven very powerful for us.
Definitely, man. That is impressive, and definitely extremely valuable model to for organizations to adopt. We had a comment from Conrad as you were speaking. He said, "That's really nice, Lauchlan, to have the AI insights integrated into the fabric of the organization." I love that. Yeah,
I think it's very nice working with a company like Woodside. It invests significantly in the things that are the current future, if you can turn something that way, but also in things that are in the future. And so AI is only part of the journey that Woodside's on. So to have it has to be integrated in the business for the business to consume it. If you have this sort of data science cell off to the side or sort of stuck onto the business, adoption and sort of business problems become a little bit sort of abstracted away from what the business is trying to do. So actually having it embedded in the business means we're answering business problems and tackling the things that the business needs answered. Very powerful in that way. Thank you, Conrad. Nice question or comment.
Oh, it's really good. It's your perspective there is really beneficial to see AI not as the end game, but as a component, because then you get to push further into the use and the adoption. And there's a follow-up comment from Conrad says, I guess not many AI projects get to have business users adopt it. A lot of good effort goes to waste by young engineers. It helps to have business people part of the analytics team, and having that further vision, as you guys do, makes a difference.
Absolutely critical. If you're not answering a business problem, you're basically doing a science experiment. So having the business people explaining the problem, because no one, when it's sort of a broad business like we run, where there's multiple assets with multiple activities going on, no single person can know everything perfectly. So asking that of your data scientists is, I think, a very big stretch. So having the business people really tightly coupled with the data scientists is very valuable. And also the point I made earlier around you deploying into the tools they're already using is again a very powerful tool. So your adoption framework becomes very narrow in terms of just understanding what the piece of information they're getting is.
Great. And there was a follow-up question from Natasha around how do you decide how to solve the problems, or what approaches you use to solve problems. Her question is, how do you decide to use visual imaging as opposed to other ways to measure measure the information, sensors, or directly measuring the amount of oil remaining. Out of the options to solve a particular problem, how do you choose which one to go with?
Generally, it comes down to cost. What's the cheapest way to get the information that you need to solve the problem? And in fact, I can't think of any other reason why you wouldn't choose cost. There are many ways, as Natasha points out. This one was visual analytics because it was just quick and easy to get to. We use other sensor information when required. We are lucky in that all our plants are heavily instrumented already just for their basic functions. So we get a lot of that IoT information as out of the box in industrial plants because they're fully censored. So there is a lot of information already, I guess. And where there isn't information, like in that site class, we could have used a level meter measurement or something else, but that would involve intervening on that piece of equipment. In this case, it was a very quick POC with would you believe, a off-the-shelf IoT camera that came with all the bits and bells and whistles that we needed, i.e. just a camera, and it didn't require any intervention into that piece of equipment. So I think every business has different cost metrics about what drive them. In our case, being remote means putting people in place costs us a fair bit of money. So using the differential cost of devices changes somewhat, doesn't make it completely different. But you're looking at what your cost drivers are within your business and making sure you're making the right decision for it. Cost drivers are not necessarily purely money either. Safety and welfare issues come into play as well.
Yeah, definitely. Uptime for the plants, I'm sure it's important, but that's a really good way to look at it because in this case you're going from it sounds like a manual approach to a more automated approach and having sorry.
The beauty of that particular example was it went from, the idea was not to create a data stream of information, but to reduce a fairly small value add role on the site. So it was an activity that the operators didn't particularly enjoy doing. It was repetitive because we were looking for an answer. To provide this solution, it certainly has empowered them because they go to that site when they need to, not just to try and discover something.
Nice.
But in doing so, we then were able to create a data stream that was able to give us a new insight into how that piece of equipment was performing. And from there, we were able to build other tools on top of that piece of information. So once you start something, you've the ability to build on top of that using a data ecosystem is very powerful as well.
Man, that is fantastic. And we have a follow-up question from Kirsten. She says, do you find times that at times you roll out a model with a mistake? If so, how does that get picked up? How does it get rolled back and improved?
So yes, the answer is yes. I think everyone is fallible, including unicorn data scientists. We have a number of means to monitor our models. And in fact, we've built an ecosystem which sort of continuously checks the veracity of the outcome. So we've created what we think is a set of bounding conditions which define what good looks like for that particular algorithm. We also run versioning so that we can run multiple versions of the same model in parallel and check how they are performing, so that we can roll back and roll forward, very much following a software development type protocol. in our data science ecosystem. The overall ecosystem sort of has a number of sort of checks and balances within it. And ultimately, we're presenting information to human decision makers. We're very much of the mind that AI is an augmenting tool and not a replacement tool, so that the humans in the loop are critical in assisting us to judge that the information they're getting is correct. So in summary, I've sort of talked around the topic, but it's a multi-layered approach. We have tests that run continuously to check that it's happening. We can run in parallel multiple versions to make sure that what we're seeing we think is correct. And we have people in the loop who know what good looks like.
That's great. And there is a lot of interest on your data and data science ecosystems. Lots of questions coming in. So I might start with a question from Sarah Dodds. Hey, Sarah. She says, curious about pushing to production in 5 minutes. Did that include a feedback loop to track performance over time and an ability for the models to evolve in response to changing conditions?
So basically, yes, the model can evolve. We can rerun it, we can retrain it, or we can have it train itself in periodic sequences. I'm probably unsure whether we have a continuously training model or whether it's, I can't think of one off the top of my head. However, we do have periodically retraining exercises. Just put some colour around what I mean by push deployment in under 5 minutes or like within an hour. It's essentially we've packaged the algorithm up. Now it can be as a complex sort of image recognition algorithm, or it can be as very simple as a sort of a linear mathematical algorithm. It's just packaged up, put into our deployment framework. It knows what data it's going to be calling. It calls the data and then publishes a result. That the execution time of that particular algorithm is generally pretty small, but they can be long. But it's sort of a consistent framework independent of the complexity of the algorithm. Now, the algorithm itself might have its sort of needs and wants around testing and retraining, and that can be done as well. So it's not, it's not that we've excluded sort of a whole heap of parts of the data science ecosystem, but the general consumer of that algorithm is looking at a result and an outcome to add value to their business, and less so about the sort of mechanics of what the data science team need to go through to manage that piece of information for them. To keep the data science team quite lean, we need to make sure that they are managing their data assets, the ones that they create, with the same attention to detail that everyone else in the business is managing their own data assets, because effectively anything coming out of the data science system is using the data science ecosystem as a source of information, and they need to govern that data. We run, last count was over 10,000 algorithms an hour.
Wow.
So adds varying complexity, and that's beyond the power of an individual to govern. So we have tools to help assist us with that.
Amazing, man. That is incredible. And yeah, we've been discussing the infrastructure to enable the data science use cases, the data preparation, the getting the results of AI to users. We've got a couple of questions around a different on a different plane, which is around other use cases or other examples of AI models in the energy sector. If you can share some others with us. There's a question from Tim and from Anna talking about what other are there any other examples that you can share?
There are a couple which I can share. I think the most The most powerful ones are probably generally the most simple. And I'm going to segue to a different answer before I come back to this, so bear with me. The other thing around working in a numerically competent organisation, but also an engineering organisation, is the physics models are very strong and powerful and accurate. So there are times when the physics models will be supreme, and there are times when the data models or the numeric models will be supreme, and the actual where the real power comes is when you can get physics models and data models to work together. And so some of the most powerful deployments have been using the data ecosystem to feed a physics model and then have that produce a raft of information. And that physics model can be as simple as diving into some of the real sort of techie stuff of our industry, but a simple choke model on a valve, or to some more complex sort of process modeling. The other thing that implies is a lot of the maths in our industry is already known, but doesn't get deployed at scale because of the problem around the data ecosystem. So having understood the maths for a long time, but then deploying that maths in a continuous data framework is one of the very powerful things that we've been able to achieve in the last 2 years. So, and then it becomes a very interesting topic about whether that's data science or whether that's engineering and physics.
Right.
But again, we're answering a business problem in a language that is going to get fast adoption and through both comprehension and accuracy. Winding back, one of the more powerful but simple tools for data science has been understanding human-entered information and being able to digitize it in a way that we can then consume as an information stream. So quite simply, in this case, we've been doing a lot of work around maintenance. And typically you'll get an operator in the field giving you a story or some written text around what they experienced when they were performing maintenance on a piece of equipment. Ultimately, what we want to know is whether that equipment was working or not. Now, there is almost an infinite number of variations around a human can describe something that is working or not working. I think some of the language that you might have used around your car when it breaks down could be interpreted multiple different ways. So creating an algorithm to actually understand that so that we can create a failure data set with high accuracy has been a very valuable activity within the business. And it's allowed us to move from a data set that was untrusted, or I'm overstating it, it wasn't well trusted, to something that it is trusted and is delivering enormous value into the business around interpreting machine performance has been possibly one of the more outstanding illustrations of how data science can look at something differently. And everyone's saying, well, we need to go interpret the machine data, when actually we went back and looked at how the humans were interpreting machine performance, then reinterpreting that as machine data. That was quite simple in concept, quite difficult in execution, and very powerful in its outcome.
That's incredible. And we have a related question from Anshu about how does that feed back to the people who are doing the maintenance or the work in this case. Is there any process where they learn back from the data that was analyzed out of what they entered?
So in this case, that information has been consumed many times. Very simply, it came back as a dashboard that told them whether a piece of equipment was working or not. So if you're running an industrial plant, you want to be very reliable, and Woodside has some very enviable reliability statistics. But equipment doesn't work all the time. And so if you're running that plant, you want to know what is working, what is not, so that you can make the correct decision about how to get the best outcome for your production day. And so very simply, presenting that information correctly and accurately to the frontline operations personnel so they can interpret that information is very, very valuable.
Mm.
In the back end, again, the engineers are then using it to look at the longevity and look at the longitudinal performance of pieces of equipment to make sure have we got the right piece of equipment in the right position within a plant, or should we be looking at something else and looking at how we can optimize in the long term. So very simply, you've got a front line and a back office people using that information based on the fact that we are now able to tell them with more certainty what the actual condition of that piece of equipment is.
Great. And we have a question from Stuart around the security and the access controls around the ecosystems that you have. So his questions is how are you building security, cyber and internal, into the information flows, controlling who can see what are there and what they're allowed to do with it?
So all the information, because we've created an ecosystem where data is consumed live, we're using an application programming interface, APIs. So there's no rocket science or secret sauce in what we've done. But in using APIs, we can put permissioning systems and we can log all the transactions that go across them. So we've got transparency on who, and we've got controls on who can access information. Having an API framework means that we're seeing far less copying of data and therefore have greater control over what it's being used for. The corollary is, or the juxtaposition of that problem is that you want people to be using data. So you've got this sort of trust and verify approach. So we can see all the transactions of people consuming data via the APIs. But we're trying to be as open as possible within the boundaries of what is permissible within the ecosystem. So not all information is available within Woodside, but we're trying to make as much as possible so that people can solve business problems using data and information. And this comes back to the more we use data as an asset, the more value we get from the activity of creating it, and the more sort of better treated and well curated that data will become, just because people are using it, people respect it, people treat it as something that they're deriving value from.
And I'm impressed with the scale of your ecosystem and what you've built, the speed at which the information flows, that the algorithms are being retrained and computing. It's fantastic.
Thank you. I'll just say it is a work in progress. We're not finished. I would hazard a guess. I'd say it's never complete because this world changes so quickly. And that's another thing. We want to be able to update ecosystem to the latest and best technology without disrupting. In fact, our consumers don't even know that we're making changes. That's the ideal. It's not that we don't want them to be aware, but they don't need to be aware that we're changing something, because as far as I'm concerned, they just want the information available. So we're trying to get that ecosystem where changes can happen in the background, and we've got these layers of separation within our ecosystem so that people can work within their layer, understand that the other people are responsible for the surrounding layers, but they don't really have to get too involved in the detail. And that allows us to keep up to date with current technology, which is changing very fast.
That is powerful, extremely powerful to have a modular ecosystem there. That's great.
A work in progress.
No, that's excellent, man. There's a question from Max about the impacts, the people impacts of AI projects. He's if there's been any redundancies related to any of the AI projects? As in, like, has an AI made people redundant? If so, what has happened to them? And Conrad made a comment that maybe this could even include cost savings in terms of, you know, having less machines broken down or anything like that may drive any requirements for less people.
So no, the answer is no. We haven't made anyone redundant based on an AI project. I think what we have done is we've automated the boring stuff as much as possible. Now, there's still a long way to go in that space. People are our most valuable asset, and I think I made a point earlier that we don't regard AI as an alternative to people. It's an augmentation. We very much view it as an augmentation of people.
Yeah.
So the answer is no. There've been no job losses due to the creation of AI tools. What was the second question?
So then it was around if any of the improvements that you've made that are, for example, on machines requiring less maintenance, whether that's had an impact on people.
So again, no, the answer is it hasn't had an impact on people. What it has done is made us a little bit more efficient and improved our bottom line that way.
Nice.
And in doing so, we're heading down a path of improving our ability to do the right maintenance at the right time, and making sure that we're using an informed reason to do the activities that we're doing. At this stage, I think the ebbs and flows of the energy industry, I think during the last year, the oil price dropped. Those type of macro levers tend to drive the behaviour around maintenance and sort of the way the industry works far more than sort of the slow evolution, the continuous evolution that every business goes through in this industry around improving how they do their business.
Yeah, that's a really good one. Question from Ryan around team structures. So he says, what team structure do you recommend for projects? Do you consider having a project manager and a product manager / owner as essentials for data science projects?
For data science projects and a data project, if we can sort of tie them all together,
yeah.
I think you have to have the business involved, and you have to have someone who's tying all the loose threads together. So I think a PO and a PM are generally a good addition to any project. I caveat that with the point that not all data projects are big projects. So having that level of resourcing on a project can be a little bit sort of over the top and financially burdensome. So I guess where I would sort of end up answering this question is you've got to choose the team that's appropriate for the size of the project. Additionally, it has to be culturally aligned to the way a certain industry or a certain company works. Every company is culturally different and has a different way of executing work. So I know even within the sort of the city I work in and the sort of heavy industries that we have surrounding us, every company has a different culture. How they execute work is very much dependent on the culture of the company that they're working within. And so the team makeup to deliver a project needs to be sensitive to how that business operates. However, I think if you're not answering a business problem, you're not going to have a successful project, and in my world involves having the business sit there with you to describe what good looks like, and having someone who's willing to sort of holistically look at how execution is going is also very important, because it's not just a data project, it's a data science elements, it's got consumption elements, it's got visualization potentially. How does it all come together? And very rarely do you have all of that capability wrapped in a single individual.
Yeah, exactly. Yeah, really good. We have a question from Conrad around the the challenges in data ingestions into the ecosystems. So his question is, how important was this? Was the data ingestion? How important was it in the overall ecosystem? And yeah, how big of a challenge was it?
I hate to quote some of these big expensive consultants, but I read a very interesting article by McKinsey who said that 5% of any company's operating expenditure was spent accessing data. So to me, that was just a huge opportunity. When you look at, so Woodside is a reasonably large company, but you look at some of the big companies, particularly some of the financial and retail institutions, and the amount of information they're trying to get at, that number must be a big number. I also felt it when I was working in the sort of data science, and we had business intelligence sort of working with us, and the amount of effort that you spent accessing that information and then going back in to get a different but similar set of information from the same system, you're like, oh, there's got to be a better way. So that's when we started doing this. If we're going into a system, we're going to go get all of it. We're going to create pipelines and that type of stuff. Again, a work in progress. We need to be able to get access to this information. The other thing is those source systems are there for a reason. They perform a valuable workflow within the organisation, and they're also the best way to make sure the data is created consistently and with high quality. So there's a very interesting dynamic there. But building those pipelines and building them well is a very, very important activity. I get that. Before we sort of started this podcast, you and I caught up and we talked about an interesting problem where your data pipelines and your data ecosystem are an investment in infrastructure. And you're sort of entrusting that people are going to use the infrastructure. And I think it's like building a road. If you're building a road, you're hoping that the destination the road ends up at is somewhere where people want to go. And so you're building these pipelines based on the fact that you're trusting that people want to get at this information and it's a valuable asset of the business. I think I stretched that sort of analogy in my head a little bit when I said the POC is like sort of creating a walking track where you go from where you started to where you want to be, and you follow a sort of little goat track, and then as more and more people walk on it, it gets more and more formed and eventually becomes a superhighway if it's valuable to lots of people. But I think
that's great.
Analogy's done.
Man, I love it. That is awesome. I'm going to close the poll now so we can go through the answers. We had about 80% of people answer the poll, and I'm keen to get your thoughts. So question one was, are your data and machine learning environments all together or are they separate? 56% of people said that they have them as separate. 44% said all together. Any thoughts from your side on that one?
I guess I've got a bias to separate because that's what we've built. It does make integration within the data science system very easy if they're together. But I think, and I've seen plenty of very powerful data science teams work that way. I guess the challenge to them is then deployment. So once you get an answer, if you're just running sort of studies and POCs, it probably works very well. Now, I shouldn't talk ill because we have of that type of ecosystem because we don't run one like that. But we do find our separation very powerful because not all data consumers are data scientists, nor are they intending to use data science tools. They just want information for automation purposes or visualization purposes or application purposes. So, so we're trying to service all of those customers with our ecosystem.
Good. It's really good. The next two questions got the same answer, which is interesting. So question 2 was, what's the most challenging part of data science projects? And question 3 was, where do you spend most of your time? And both got over 50% of people voting for data preparation. And then, yeah, it looks like the next highest one for spending your time was on data exploration, and on the challenging part, the second largest one was for putting things into production. Really interesting. Any thoughts from your side?
I can't disagree with that. It is spot on what we saw. And the problems that I think the problems that we recognised and tackled head on early on in the piece, and I think we're well down a journey to sort of having those problems not solved but minimised for our part of the business. Industrialising the ingestion patterns and the data acquisition has been a bonus for the business, and we're seeing more investment in that area. And then getting to the point where we have a deployment framework that works most of the time, is suitable for most of the data science projects. There is, as with everything, there are step outs and different outcomes, but most of the time we can get a data science algorithm out pretty quickly. And that leads to the scale of the number of models that we run on a consistent basis, because the framework's very easy. So yes, they're very challenging, I think, and everyone likes the sort of creation of insight and value that the data scientists do, but there's sort of heavy lifting at both ends that need to be resolved. So how do you make the fun stuff and the boring stuff automated? Right.
Yeah. And I would have expected a lot more time on user adoption, and for more people seeing that as a challenge, at least from my experience.
One of the observations, I think, this is a Lauchlan observation, and probably not a Woodside observation, if I can make that distinction. The various different types of industries have different adoption problems. If I look at my iPhone, everyone looks, and it's just here next to me, that's why I looked away. Everyone looks to that as an example of digitization, and what the digital future may look like. I looked at some of the applications on there and the amount of time I actually spent looking at them. And I don't know, pick a famous one, I don't know, Google Maps. I might look at it for 10 minutes a week. I wouldn't live without it, but it's not an ecosystem I'm immersed in constantly. But adoption's good, and its scale is by volume. And I imagine they've invested a lot of money in it. Now, if my company had invested a similar amount of money in an application like that, but was only getting me looking at it for a couple of minutes a week, I think they'd be disappointed. So there's a different scale of how adoption happens within different industries and with different ecosystems and different work environments. And it's a challenge. One of the challenges we sort of took on was trying to deploy into existing tools so that we didn't have to have an application adoption problem as well.
Yeah.
But the sort of corporate ecosystem where you're sitting in tools for long periods of time is not the sort of consumer experience of applications. It's, I guess, an observation Lauchlan makes.
Yeah, man, that is very true and very, very important. And yeah, I know that at least in my case, we track the usage of the data that we create and the insights, the dashboards, the models, and how frequent they're being used by how many people. And we definitely expect our work to be used more than 10 minutes a week. So that's a really good point.
You'd like to think it was the critical business solution that you'd solved.
Yeah, exactly. And the last question in the poll was around a citizen data science framework. And the majority of people, 88% of people said that their organization does not have one. 12% said that they do have one. What is your perspective on this?
Look, Perth's a very isolated city, and we don't have the luxury of riches in the sort of data science ecosystem to solve every problem for the business. So our tactic is to enable our business to solve some of these problems themselves. I think the experience of data science is that you get a lot of low-level, low complexity requests that can be quite comfortably solved by a numerically literate individual given a right tool set and tools. But yes, we're enabling citizen data science as much as possible. And in fact, our data ecosystem for the longest time has been called the citizen data science ecosystem, to enable that sort of thought process and concept of consuming data, being able to build your own insights off it. And you're starting to see tools that are coming to the market and coming to the ecosystem that allow that to happen. I think the first round of tools were very confronting in terms of the average user, but now some of the more modern tools, Microsoft Suite, some of the stuff coming out of other vendors is starting to enable that to happen. I look at the big data concept, if you call it that, and it was very much power sort of visualization of information was the original sort of concept of it. And then when the mathematicians got hold of it, and you're sort of moving into more and more complex maths, from simply visualizing data to the next step around applying algorithms and mathematics to large data sets. For the longest time, that's had a barrier to it around code literacy. Now that code literacy barrier is coming down, but I still think it still exists and will continue to exist in the more complex realms where sort of coding and is required to get big data into complex mathematics. If you look at some of the physics tools that I talked about earlier, they don't actually require a lot of input. So they can do very complex mathematics, but they don't require big data. So this ecosystem of big data and big complex mathematics is the world of data science, and it still has a barrier around coding, which is slowly getting solved.
Yeah, definitely improving over time. I know that we are out of time. I see some people have a few people have dropped off, so which is understandable. So we will leave it there. But Lauchlan, the amount of comments and the amount of questions that you're getting, this is an area of huge interest to the audience, and they were very, very excited to hear from you. Comment from Conrad there. Enjoyed it. Great success. Yeah, Lauchlan, thank you so much for coming on the show, sharing your journey, your perspectives, the amazing work that you guys have done. It's been fantastic to get an insight into the great work that is going on in Perth. So thank you so much for this.
Look, thank you very much for having me. It's been an absolute pleasure. It's a story we're still creating, so maybe we'll have more stories to tell in the future. But I really enjoyed it. Thank you very much.
That'll be great. Definitely keen for a part two. People are saying yes, thank you. Great to hear. Great for the share. People say thank you. Heather says thank you, very informative. So mate, thank you so much. Thank you to our sponsors for allowing us to create this content. So Yellowfin, Databricks, Ambiata, Talent Insights, definitely big shout outs to them. And also shout outs to people that were particularly active in the chat and with their good questions. So today we had Conrad, Natasha, Helena, Kirsten, Stuart, Sarah, Anshu, Anna, Antoine, Ryan, Tim, Max. Thank you so much for your participation, and very keen to continue to have the chat and the Q&A as active as it was in this session. Thank you so much, everyone. For the people that have registered for the series, you will be getting the recording by email. and come back next week for episode 13 of Advancing AI series. Thank you so much, everyone. See you then. Lauchlan, that was amazing. Thanks again, mate.
Thank you very much.
Have a great day, everyone. Thank you. Bye. Thanks for watching this video all the way to the end. I hope that you got a lot out of this discussion. And if you're watching on YouTube, please like and subscribe to the channel so more people can find out about the challenges that leaders have in the analytics and AI space. And that's what we're trying to share in Data Futurology. So please like and subscribe. And if you enjoyed today's episode, please tell your friends. Thank you so much.